This video is going to review how you do two special types of division, that is polynomial long division and then synthetic division, which is a kind of a shortcut version of long division if depending on what you're dividing by, if you're dividing by something linear. So we're going to do two of each, two with the long division and two with the synthetic division to have a little bit of extra practice. So first thing you want to do when you start off with a long division is you want to write it like a long division problem that you would have done in earlier schooling. So we're going to take what we're starting with, the x cubed minus 3x squared plus x minus 8, that goes under the division bar. And then we're going to put what we're dividing by outside of the division bar. A couple things to keep in mind. If you're missing any terms, what I mean by that is this has a cubic. A cube first degree is third, and then it goes down. You should then have something to the second power, and then to the first power, and the constant. If you are missing any of those, you want to keep a 0 as a placeholder. That doesn't happen in this one. It will in the next one we talk about. What we want to start off by saying is what happens when we take x cubed and divide it by x. Or another way that a lot of students kind of help understanding is figure out what would I multiply x by to get it to be an x cubed. And the answer to that is x squared. So we are going to put the x squared above the squared column. It's really important to keep your columns lined up in this technique. So we keep our squareds on top of our squareds and so on. Then we multiply. We're going to multiply x squared times x. We get x cubed. And then we're also going to multiply x squared times negative 1. We get negative x squared. Then we're going to subtract, and when you subtract it changes your sign. So this is going to be a minus x cubed and it's going to be a plus x squared. This should cancel. If it doesn't, that tells me that the number, that what you decided to put up above, that x squared, was not the correct term. And then these should combine. Negative 3x squared plus 1x squared is negative 2x squared. Then you go through the process again. You want to figure out what happens if I take negative 2x squared and divide an x out. Or another way to think of it is what do I have to multiply this x by to get it to be a negative 2x squared? And that would be a negative 2x. Then we multiply. Negative 2x times x is negative 2x squared. And negative 2 times negative 1 is positive 2x. Then we subtract. When I subtract, it changes the sign. So this becomes positive, so it will cancel, and this becomes negative. Now I have an x minus 2x, which is negative x. Then I drop down the negative 8. And then I'm going to do it one more time. I want to figure out what negative x divided by x is, or again, another way to think of it is what do I multiply this x by to get it to be a negative x? And that would be a negative 1. So I have negative x, and then negative 1 times negative 1 is positive 1. Subtract, so that's going to make this positive and this negative. You are left with negative 9. That is your remainder. The way you should write your answer is you're going to write first what you got when you did the division, x squared minus 2x minus 1. And then my remainder is negative 9, and you're going to write that over the original piece you were dividing by, x minus 1. So that is your final answer. It did have a remainder. We did some in class that do, some that don't. This one did have a remainder. Here's another version of long division, but this one has a little things to consider with this. The biggest being you have a lot of terms that are not there. So when I write this down, I'm going to have a 2x to the fourth, but then I'm going to have a 0x to the third, a 0x squared, a 0x, so I have a lot of placeholders, a lot more than normal, and then a plus 7. And then I'm going to do the same thing with what I'm dividing by. I have an x squared, I don't have any x terms, and I have a minus 1. So it gets kind of long when you put all those placeholders inserted in there. Same process. I want to take the 2x to the fourth and divide it by x squared, or in other words, what do I multiply x squared by to get it to be a 2x to the fourth? The answer is you need a 2x squared, so I'm going to put that above the squared column, and then I'm going to multiply. So I have 2x squared times x squared is 2x to the fourth. 2x squared times 0x is 0x cubed. 2x squared times negative 1 is negative 2x squared. When I subtract, this is going to cancel. This wasn't there to begin with. This is going to become a positive. So I have 0x squared plus 2x squared, which is 2x squared. Now I'm going to bring down my next term. And then I'm going to do it again. 2x squared divided by x squared, or what do I multiply x squared by to get it to be a 2x squared? The answer to that is 2. So I'm actually going to put it above the 7, in that kind of keeping the columns in order, because that's a constant. So 2 times x squared is 2x squared. 2 times 0x is 0x. 2 times negative 1 is negative 2. I am going to need to bring this 7 down, because I hadn't already. When I subtract, this will cancel. This already is gone. This becomes a positive. This one also has a remainder. This one has a remainder of 9. So the way you want to write your final answer is 2x squared plus 2, that's what you got up here, plus a remainder of 9 over my original divisor, x squared minus 1, so over that piece. So there are two examples of long division, one where you didn't have any placeholders to worry about, and this one where you had a ton of them. A lot of times you'll have a placeholder here or there. This one was definitely excessive with a lot of placeholders, but it definitely makes you practice it. The second way that we do long division, and we call it synthetic division or dividing synthetically. Synthetic division is a great technique, but it's very specific to when it works. It works when what you are dividing by is a linear piece. So as long as you are dividing by x plus a number or x minus number, synthetic is definitely the way to go as far as time that it takes to work with it. When you set up your synthetic division, you want to put your coefficients inside the box in the top row. Again, if you didn't have a coefficient, for example, if you did not have an x term or an x squared term, you would have to use 0 as a placeholder. This first one doesn't have that issue. We have 4x squareds, 5x's, and negative 4 is my constant. What goes outside of the box is actually the 0 of what you're dividing by. So you don't want to put 1 outside the box. You want to figure out what makes x plus 1 equal to 0, and that would be negative 1. So the 0 goes outside the box, not the actual number that you see there. It's actually the opposite of it. The way synthetic division works is you drop down the first number. You're going to multiply diagonally, so negative 1 times 4 is negative 4, and then you're going to add vertically. Then you're going to multiply again. Negative 1 times 1 is negative 1. Then you're going to add vertically. This represents 1 degree lower than what you started with. So you started with an x squared. So this represents the x's. This represents the constants. This represents your remainder. So my answer is 4x plus 1. And then your remainder is minus 5 over x plus 1, the original piece that you were dividing by. So again, as you divide, you drop everything down by 1 power. So that first number in this case would represent x's, and then the constants, and then remainder. Next one, very similar, although we do have a placeholder here when we set this up. We have 1x cubed. We have no x squared, so I have to put a 0 there. We have negative 14x's, and we have 8. What we are dividing by is x plus 4. So the 0 of that is negative 4. That is the number that goes outside. Again, we drop down this first number. We're going to multiply diagonally, and we're going to add vertically. We're going to multiply diagonally, add vertically, multiply diagonally, add vertically. Something special that happened with this one is we actually end up with no remainder. We have one that actually was a factor of it, so no remainder. But we still have to write down what my answer means. Now remember, we started with x cubes. So when we divide, we are left with, this is your x squared column, this is your x column, this is your constant. So your answer is 1x squared, or just x squared, minus 4x plus 2. No remainder, so I don't have to write anything else. So it gives you a chance to practice the two types of division. Obviously, we'll go further with it and use it more, but it's nice in the beginning to be comfortable doing either long division or synthetic division.